the combined abundance table that you just produced for all your samples using merge metaflow tables is a flexible format. It's a white space delimited file that you could import into Excel. You could turn it into a R or Python data frame if you know how to do those things. So there's a lot of different analysis that you can take that table forward into, and we can't explore all of it today in the tutorial, but what we are going to do is make a heat map. And a heat map is a common exploratory visualization of your metagenomic data, which is a good starting point to think about what else you might do. And then in the workshop on April 15th, we will get into some of the statistical analysis that you can do with those abundance tables. So what we want to do right now is filter our abundance table down so that we are only looking, and for the purposes of this exercise, we're going to only look at genus level classifications. And how we do that is what we showed in the last videos. We are going to use grep. So grep minus E. And we're going to look for a pattern that includes either genus or something that we find on the column header line of the file that we created. So ATE is a label of one of our samples. We'll only find it on that line and not anywhere else in the file. And we want to preserve our column header. So that's why we want to do that. And then I want to do that on the stream abundance table.txt file. And then I'm going to grep again, this time to exclude. So grep minus V, and the pattern we're looking for here is F. Okay, so we want to, or sorry, S. So we want to have genus level, but not species level classification. So then after this, what we want to do is actually edit the lines on the fly so that we have more simplified names or more simplified row names in each of our entries. And we're going to use that little on-the-fly editing program called SED. Okay, and SED we're going to look for, we're going to do a substitution, and the pattern we're going to look at is actually a little bit complicated, and you'll have to, SED is something that takes a little bit of thinking to learn to work with. But what we want to say is we're looking for from the beginning of the line, okay, to the last instance, or to whatever number there are instances of this pipe operator character, which is used as a separator in the metaplan output. And so the star is saying however many of these pipes there are, we're going to replace from the beginning of the line to that last one is the effect of this command. And then we're going to the second field in the substitution is nothing. We leave it blank. We don't even put a space there. And then G, okay? And that is going to give us a edited down file that looks like. So we'll stop there for a moment. So here we have only the genus information, and we have only classifications by genus. Okay, so now let's go back to that command and add one more thing. And I want to use my SED to get rid of part of the column name. So all of my column names, and let's see, let's go back and look at that quick. All of my column names in this file have dash profiled at the end of them. And I would really like to just have ATE 49, ATE 50, whatever. So to make that happen, I'm going to put another SED here, and I will do s/profiled, okay, and // so leaving, basically we're taking that pattern and, sorry, that's not gonna work. We're gonna put the dash at the beginning, and then / to just get rid of that and not substitute any other characters, and then quote. And so before we write this to a file, we can make sure that looks like what we want it to look like. So scrolling back up to the top of all of these classifications. Actually, I can do this in an easier way. We'll run that through head -1, okay? And this is now what my header line looks like. So I've gotten rid of that inconvenient longer name in the file name. So now we know that this looks like what we want. We don't want to take only the header this time, and we want to write that out to stream abundance table genus.text. Okay? So now that we have this information, we can actually take that directly into HCLUS2. So that's what we'll do next.